little note page describing how to do these word problems. Okay. Um, we're going to use this form. There's a couple of different ways to do these problems. We're going to use this formula here. Okay. Where T, I'm going to get a highlighter. Where T, T is the total time with two people working together. T1 is going to be the first person's time to complete the job. And then T2 will be the second one. Okay. Second person's time. All right. And the total time obviously is going to be the addition, the sum of T1 and T2, right? You guys ready for this?
Is it the same thing where we had to find the LCM?
Yes. Once we plug in the T's, what we have, then there's going to be a T that we have to solve for, whether it's T, the total, or one of the workers' hours. And of course, you know how to do that because you got quiz done on Friday, right? So let's turn back to page 39. And let's concentrate on that formula. 1 over T equals 1 over T1 plus 1 over T2. All right, let's read through this. Working alone, Jasmine can sweep a porch in 9 minutes. So there's my T1, right? So T1 equals 9 minutes. Stephanie can sweep the same porch in 12 minutes. So there's my T2, 12 minutes. Find how long it would take them if they work together. So we need to find our total time, right? Find T. All right, let's set this up. Let's see, 1 over total time, which is what we're trying to find out, right? That equals 1 over T1, and my T1 is 9, plus 1 over T2. T2 is 12. There's my equation, so all I have to do is solve for T, right? Now, I got to find the lowest common denominator. Um, or lowest common multiple. 3 is a factor of 9, and it's also a factor of 12. However, I'm looking for a number that both 9 and 12 can divide equally into. So, in other words, I'm not looking for the factor of these, I'm looking for the product, right? Now, I could just multiply the two denominators together to get a common denominator, right? But I don't want to work with such large numbers. Um, Looking at the 9 and 12, remember, nines multiples of 9 are 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27. I'm looking at the multiples of 9. 9 times 4 is 36, 9 times 5 is 45. Let's put some multiples of 12. 12 times 1 is 12. It's 36, right? 24, 36. So in my LCD, I'm going to put 36 for the numbers. But looking at this fraction, I also need a t. So there's my lowest common, I should call it a multiple. Don't forget, I have to distribute to every fraction, right? So looking at this t, I'm going to multiply that t by, well, the t's are going to cancel, so I'm going to multiply that 1 by 36. Second fraction, I'm going to multiply by 36t. Well, 36 divided by 9 is 4, and the t stays with it. So 4t. This one, let's see, 36 divided by 12 is 3, and I'm going to need that t. Okay? 1 times 36, 36. 4t times 1, 4t. 3t times 1, 3t. Okay, so 36, I'm going to combine like terms, equals 7t. Going to divide by 7. So my t is going to equal, I need a calculator. See, 36 divided by 7. Oh, 5.1. So about 5.14 minutes.
That's it.
That's it. Questions? All right, number 2. Working alone, Jennifer can wax a floor in 13 minutes. One day, her friend Jose helped her, and it only took 5.32 minutes. How long would it take Jose to do it alone? Okay, let's see our T1.
I think first.
We'll call it 13:1 Jennifer's time, right? 13. T2 we'll call Jose, but we don't know. Uh, we don't know how many minutes Jose is. So this is the one we have to find. And then the total time they give us, 5.32.
So we're subtracting the total time from 13.
Well, let's put it in our formula. Okay, so I have 1 over t, which is 5.32, equals 1 over t1, which is 13, plus 1 over t2, which is what we're trying to find out. Okay. Let's see, I need my LCD. The first one, I need a 5.32, and the second one, I need a 13. Now, normally, we would try to find the lowest common factor here, multiple, right? That's going to be pretty hard with a decimal. So this time, I'm just going to multiply the 13 times 5.32. I got my 13 times 5.32. It's going to give me my LCD, or lowest common, or LCM, whatever you want to think about it. 69.16. So I took care of these two fractions, right? And then I need a T2. Okay, I'm going to multiply every fraction by my LCM. Okay. Let's see. 5.32 divides into 69.16 13 times, right? So I'm going to multiply this by 13 and the 3, 2. So that cancels out there. This one, I'm going to multiply, let's see, 13 divides into 69.16, 5.32 times, right? And I need that T2. Takes care of that denominator. Then I'm going to multiply this. Let's see, T2s cancel out, so I have to multiply it to the 69.16. Takes care of that denominator. So here's what I have left. Let's see, 3T2, I'm sorry, 13T2 equals 5.32 T2 plus 1 times 69.16. With me? Okay. Get my T on one side, so I'm going to subtract 5.32 T2 from both sides. See, 13, I'm going to use my calculator. 13 minus 5.32. So you have 7.68 T2 equals, these add up to 0, 69.16, and then divide by 7.68. So my T2, let's see, 69.16 divided by 7.68, 9 minutes. We good? No questions? Oh, you guys are good. All right, number 3. A diesel train made a trip to Las Vegas and back. On the trip there, it traveled 40 kilometers per hour, and on the return trip, it went 90 kilometers per hour. How long did the trip there take if the return trip took 8 hours? Okay, so we've got one of those rate. You guys remember the distance equals rate times time formula? Distance equals rate times time. So that's the one we're going to use. So my
Do the whole term process again for 2, 1, 7.
say say that again.
Do we have to do the formula again for?
Well, we're not going to use this formula. Okay,
Alright.
we're going to use this formula where distance equals rate times time. Okay. All right, let's fill in what we know. Let's see, we got a trip going there. So here's there, and this will be return. Okay, let's see. They give us a trip there is 40 kilometers per hour. So that's my rate, right? So the trip there, my rate, 40 kilometers per hour. Let's see, how long did the trip take there? So the time for there, we don't know. So that's where we're going to put our T. Okay. What else do we know? Um, on the return trip, it took 90. There's my rate, 90. And that took 8 hours, right? So we have the time for that one. So we can find our D, right? Our distance is going to be rate times time. So the distance equals rate times time is 40t going there. And the distance coming back, return, is 90 times 8, which is 720. Now, the distance coming back has to equal the distance going there, right? Distance doesn't change. So that's what we're going to use for our equation. I know that this distance, 40t, has to equal 720 miles or kilometers, whatever it is.
It will hold 18 hours.
18, right? Divide both sides by 40. And it took 18 hours to get there.
That would be easier.
Yeah, it's not too bad, huh? All right, number 4. Fishing boat left the Azores and traveled towards St. Vincent at an average rate speed of 25 kilometers per hour. Cruise ship left sometime later traveling in the same direction for 30 kilometers per hour. After traveling 5 hours, the cruise ship caught up with the fishing boat. Find the number of hours the fishing boat traveled before the cruise ship caught up. All right, going to use distance equals rate times time again, right? I'm going to add my distance. That's going to equal my rate times time. Okay, so I got the fishing vessel and then the cruise ship. All right, let's see what they give us here. The Azores traveled speed 25 kilometers. So I know the fishing vessel was 25 kilometers per hour. The cruise ship, 30 kilometers.
So again, 5 hours.
And it took 5 hours for the cruise ship. So what are we looking to find here? The time of the fishing, right? This one. Oh, I'm sorry. Somebody messed with my camera while I wasn't here. All right, so my distance then for the fishing vessel is 25t. And then 5 times 30 is 150. And again, the distances are the same, so I'll set those equal to each other. Have my 25t has to equal 150. And how many quarters in a buck 50?
Six.
Yep. So t equals 6. I'm sorry, what?
Is it just 6 or 6 what?
6, what is it, hours? Yep, 6 hours. Took the fishing vessel 6 hours to catch up. So the next problem is a little tricky. All right, 12 pounds of sliced peaches, which cost $9 per pound, were combined with 6 pounds of sliced bananas, which cost $6 a pound. Okay, so we're going to need cost, right? This one, we don't really have a specific formula, right? So we've got to reason this out. They both cost something, right? Let's see, cost dollars. We'll use dollars, right? We have peaches. And bananas. Okay, what else are we going to need? Well, they both have pounds, right? We're going to need pounds. And then, what else are we going to need? Cost, pounds, cost per pound. So we need the total cost, right? Okay, let's see if we can fill some of this stuff in. For the peaches, $9 per pound. And then we have $6 per pound for the bananas, right? Let's see, we have 12 pounds of peaches. And then, let's see, 6 pounds of the bananas, right? Okay, so the total cost here is going to be, well, we're going to multiply these, right? That's going to equal like total cost. 19 times 12 is going to be 8. 18, 10. 18, 10, 9, 10, right? $108. And then this is going to be $36. So we're supposed to find out the cost per pound of the mixture. So we really don't need the cost in our final. We need pounds per mixture. So let's see. Let's
Total would be 100.
yeah, let's add these together. So on this side I've got, let's see, 144 cost, right? How many pounds do I have? 18 total, right? I have 18 total pounds and it cost me $144. All I really have to do is take that 144 divided by the 18 pounds. It'll give me the cost per pound. I told you this one was a little awkward. 144 divided by 18. Did I do that right? Nope. 144 divided by 18.
Yeah.
Much better. $8 per pound. And that's what I was supposed to find. Cost per pound. You can almost do that one in your head. It almost is more confusing making it all out into a chart. I think they use this one to set up this one. Mixture problems. How many gallons of 80% sugar solution must be mixed with 10 gallons of pure water to make a 30% solution? Okay. We're going to need a chart.
So one's gallon.
Yep, one's gallons, definitely. See, gallons,
Does that
percentage of pureness, right? And then we'll need the total. Okay, so we'll call it sugar and water, right? Pure. Okay, 80% sugar. So here's my 80. And it must be mixed with 10 gallons of pure water. So we know the 10 gallons is here, right? Water doesn't contain any sugar. So 0%. We're trying to find the gallons, right, to make a 30% solution. Ooh, we're going to need a third row because we need that 30%, right? We need the 30%. And actually, these should be points. All right. Let's fill in the rest. Let's see, my total here, 0.80 times x is going to be 0.80x. 0 times 10 is 0. Ooh, how many gallons are we going to have total?
I have a quick question. Why is it
Well,
0.80?
I'm sorry, what? Aiden?
Why is it 0.80?
They're percentages. Remember, we got to move it over 2 decimals. Okay. Keith, what was your?
8%. Oh, 8%?
Well, we're looking at gallons.
10x.
The mixture, the 30% solution is going to be how many gallons?
10
10. What about this?
x gallons.
So x plus 10, right?
Okay.
So the total in this one is going to be 0.30 times x plus 10.
Oh, no, that's what it is.
Okay. All right. This still isn't too bad. So I've got my 0.80. This total and this total is going to equal this total, right? So I got my 0.80x plus 0. It's going to equal, don't forget to distribute, 0.30x plus 3, right? 0.30 times 10 is 3. So I'm going to subtract 0.30x. So that's going to give me 0.550x 3.
You don't really need to include 0.
Yeah, no need to put the 0. So I'm going to divide both sides by 0.50. Okay, so I'm going to take my 3 divided by 0.5, and I get 6. Now, let's make sure we answer the question, okay? Says sugar must be mixed with 10 of pure water to make 830. How many gallons of 80% sugar solution? So 6. We're good. 6 gallons. Sometimes we'll have to plug it in somewhere else. Boy, was that fun. I bet you guys wish you had more. Well, you know what? I do have more for you.
Are we gonna have homework?
Yep.
You don't really have time to do it.
Nope. So we'll leave some time in class tomorrow. We should. I think we should be able to do page 43. Yeah. 6 problems. So page 43 for homework. And again, we'll have time to work on it in class tomorrow as well. So you don't have to get it all done in 7 minutes. Questions, comments, concerns?
Right, we should be able to open up the class or school.